Hi, welcome to this video. I thought I would do something a little bit more fun this time. So previously I've been doing videos to do with space, astronomy, things to help with the teaching if you're studying, things like that, as I'm a senior lecturer in astrophysics. And that's the kind of stuff I've been doing. But I thought I'd do something a little bit more fun because I actually also really enjoy food. That doesn't really come across. And what I have done is I've come across these really interesting chocolates. So we've got these chocolate planets, got the solar system basically in chocolates. And as a planetary scientist, I thought I'd kind of sample them, see what they're like, see how they compare to what the real planets might be. Are they comparable or not comparable, but are they dense, less dense? Do the flavors really work with the type of planet that it actually is? So let's kind of have a look. So we've got the sun as well, we've got the 8 planets. So we kind of switch it over. We've then got these planets here. So we've got the sun here, then we've got Mercury, Venus, Earth, Mars, got Jupiter, all the gas giants, things like that. So we're going to go from the inner solar system to the outer part, and we're going to see what those flavors are like, to how I think they should be. As a planetary scientist, as a scientist who kind of studies planets, do I think those flavors, those textures work well for the actual planets themselves? So we'll start with the sun. Now, interestingly, the sun here is kind of like a yellowy orange colour. So I don't know if you can see that. If I can bring it up to the camera, maybe is it going to focus? There we are. So this one here says that it's that orange cream. Now, interestingly, with the sun, when we look in the sky, kind of from the surface of the Earth, it does look kind of yellow, orangey. But the wavelengths of light that the sun is giving out actually peak in the green part of the spectrum. Now, it's not really a green star, but if we were to go into space without the atmospheric effect, because actually what happens is the blue light gets scattered out and it appears more yellow because we lose that blue light. But we kind of see it as white in space because we've got a collection of all these different colours that kind of add together to give us the white. But it technically peaks in the green part of the spectrum. So this one here is orange cream. Now, again, the sun is kind of like a ball of plasma, should be fairly light maybe, but it's also the hottest thing in the solar system. It's in the center. That's the thing that's heating up all of our planets. So actually, I think that kind of works quite well. Feels quite light. The outer layers of the sun are going to be fairly low density. Obviously, the center part will be quite dense, but I think actually that works quite well. But in reality, it's not really yellow or orange, so maybe the flavour, we could change that for something different maybe. Now, what we're then going to do is work towards the outer planets, working from Mercury. Now, Mercury is the closest planet to the solar system. Not the solar system, I should say the sun actually. It's in the solar system, so it's the closest planet to the sun. It's a rocky planet, so we've got Mercury here. So what I would expect from this, it's a terrestrial planet. So actually these 4 here, we've got Mercury, Venus, Earth, and Mars. They're all rocky planets. I'd expect them to be fairly dense. So planet-wise, they've got the highest densities here. The other ones are more gas giants or ice giants. They're lower density. I'd expect a lighter kind of texture to them. A bit like the sun, I suppose, actually. So with Mercury, I'm expecting something a little bit more intense and a bit denser. And this has got a flavour down as a chili cherry ganache. That sounds good to start with. It's going to be hot. Let's see what kind of it's like on the inside then. Wow. I don't know if you can see that. I think that flavour kind of works quite well. I'm getting a bit of the heat there. Again, it's the closest to the sun. I'd expect that to be fairly hot. I'd also expect it to be quite crunchy and quite firm, and it is. You kind of nice little bits inside, got a nice crisp to it. So I think Mercury works quite well. Now, if we have a look at Venus, Now, interestingly, Venus is the second planet from the Sun, but it's also the hottest. Mercury is not the hottest planet in our solar system. It's actually Venus. And the reason for that is because of its atmosphere. It kind of works a bit like global warming does here on Earth, traps the heat in from the sun, and it makes it the hottest planet in the solar system. So what I'm expecting here is probably a little bit more of an intense flavour, actually, with Venus. Now, Venus also has a liquid core. Well, not a liquid core, but it has a molten inside, so I'm expecting maybe a softer inside to that. And yeah, more of an intense flavour, really. But this flavour down here says it's peachy cream. That feels a little bit too soft, really, for what I would expect Venus to really be. So the texture is quite soft, quite smooth. That kind of works well given the interior structure of Venus. But I think the flavour is quite subtle. And I think actually a more intense flavour there would work a bit better for Venus, given the fact that it's actually the hottest planet in the solar system and not Mercury. So now we're going to try Earth. Now Earth, again, like Venus, has a molten inside. It's not completely molten inside, has kind of a solid iron core as well. It's actually the densest planet in our solar system, so I'm expecting it to be fairly heavy texture-wise. Flavour-wise, I don't really know what I'd kind of give that for Earth, if I'm perfectly honest. But I'm expecting at least texture-wise inside for it to be fairly soft, maybe something hard in the centre. And it is actually the first planet from the Sun, and they've all gone, to actually have a moon. So Mercury and Venus don't have moons. Earth is the first terrestrial planet to have a moon. We don't have any moons here. We've just got Earth. So I'm expecting maybe something soft inside. But this one says it's praline cream. So that sounds maybe promising. And actually, if you can see that, if I can get it to focus, maybe if I get my face out of the way, any better. There we go. So it's kind of got a soft, it's got a hard, crispy crust. Again, that's kind of what the Earth has. It's then got a soft bit kind of in the middle, not in the middle, kind of in the, between the center part and the outer crust. That would make sense. That's kind of where the molten part of Earth is. So texture-wise, it kind of works quite well. I suppose actually the flavour works well. It doesn't seem to be bad or good, but yeah, texture-wise and the structure of that seems quite nice. Works well for Earth. Now I've come to Mars. Now, one criticism I probably have here, but that's probably because of the flavours they're using, is that the colours don't necessarily match the true colours of the planets. So if you can see that one there, again, I'll try and get it to focus a bit maybe. It doesn't really come out here, but it's kind of more of a purpley colour than a red. So Mars is quite red due to the iron oxide on its surface, and actually if you look at it through a telescope on Earth, and even naked eye in the sky, it will appear quite orange and reddish. This is actually more like a pinky purple. Now with Mars, I would expect it to be, as we're getting further out, they're getting cooler. There's less light from the sun reaching them, they're getting a bit colder. So maybe we don't need quite so intense flavours there. That's just my opinion though. But also, Mars doesn't have any liquid core anymore. It's smaller than Venus and Earth, a bit like Mercury, not quite as small as Mercury. So it's cooled down, it's solidified inside. So I'm not expecting a soft interior there. So I would also probably expect maybe a bit of a crunch to it. It's a terrestrial planet, it's rocky, it's quite dry. Maybe I would expect a bit of a crunch there. Maybe, like some honeycomb or something like that. But it says here that it's caramel salt. So maybe we've got some big bits of salt in there. That'll give us a bit of a crisp or a crunch, I suppose. And we have. Maybe we can see that again. So we get in the centre, we've got quite a hard, crispy bit. And you have got some of the salt there, which I suppose works quite well, given it's a rocky surface as well. But it is a little bit soft, which is not necessarily representative of Mars. But I think, yeah, texture-wise, yeah, the flavour kind of works well. And the salt kind of works well, the fact that it's kind of like a rocky planet as well. Gives it like kind of like a bit of a texture to the surface that you might expect. So now we're going to move to the outer planets. Those first four were the inner terrestrial planets. They're rocky planets, they're higher density, they're smaller, they don't have big atmospheres. These outer ones here, so we've got Jupiter here, we've got Saturn, we've got Uranus, and then Neptune. Now, Jupiter and Saturn are bigger than these two. These are true gas giants, so you've got Jupiter and Saturn, they're true gas giants. They're relatively similar composition-wise, size-wise. Jupiter's obviously bigger. Then you've got this pair here, Uranus and Neptune. They're technically ice giants. They're not really gas giants. They're smaller. They still kind of have a gaseous atmosphere, but it's not as significant as the other two. So we're going to expect maybe slightly different things from those two there. Two different pairings we've got here. Now, Jupiter's the biggest one. It is fairly low density now. So I'm expecting like a really light, maybe fluffy inside. Maybe that's asking a lot. But that's what I'd expect. And also, all four of these, it depends on, we don't really understand planet formation that well, but one of the particular mechanisms we get these planets is from having a rocky terrestrial planet like these, and it just carries on growing and it actually accumulates a big gaseous atmosphere. So inside of these, we could have little terrestrial planets. So maybe we've got kind of something in the center that's hard, surrounded by something nice and soft. That would be representative of the true planets. Now here we've got Jupiter down as praline. And again, we don't fully know if they've got solid cores, but one of the theories suggests that they might do. So what I'd expect from Jupiter is something kind of quite light and fluffy on the outer part, and then maybe something hard on the inside. And I've dropped half of that one, but we're almost there. So there you go. In fact, the outer crust layer, compared to the other terrestrial planets, is quite soft. That kind of works well. Mars, Mercury and all that had a very crispy outer crust, which is kind of how we expect the real planets to be. Jupiter got really soft kind of outer layer, and then it's really soft praline inside. Hasn't got anything hard in the center. Maybe we could kind of pop a nut in there, that would work really well. A hazelnut in the center would work really well, and it would kind of represent what the real planet might be like. So now we're going to work towards Saturn. Again, the colour here doesn't really match what the real planet is. Saturn is more kind of like a yellowy orangey colour, and you'll see that in the sky naked eye if you were to look at that, or even through a telescope. So colour's not quite right, but that's probably because of what it's actually made of. So here it's saying it's mocha cream. And I guess actually that could probably work quite well, although I probably would have switched those around actually for Jupiter and Saturn, because Saturn's getting colder now. And I'd expect kind of maybe a more intense flavour with Jupiter than with Saturn. But again, inside, same structure as Jupiter. We've got a soft inside, I'm expecting. It's a huge gaseous envelope around a potential rocky or solid core in the centre. So maybe something solid like a nut inside would work well. But also with Saturn, it has this extensive ring structure. Now that ring structure is predominantly water ice. And as they're getting further out, they're getting colder and colder. So we could actually have something in there to give us a bit of a crunch as well around the outside, because we've effectively got a lot of water ice around the outside orbiting Saturn. So let's have a look kind of what's inside. And that one, it's all fell apart everywhere on me. We've got quite a crispy outer layer, actually, more so than Jupiter. I guess we could probably, that gives us a bit of a crunch, as I was talking about with the actual rings. Then we've got a bit of a soft outer bit, and again, not quite in the center, but there is actually a hard part. I guess it could kind of be in the center, but it's not perfectly in the center. That might represent that solid core that we expect to be there from the formation process. And the flavor is a lot more intense than Jupiter, so flavor-wise, we'll probably switch those around because we're getting cooler and cooler. So maybe we would get a less intense flavor, but that's my ideas. I'm probably wrong there. Let me know anyway what you think. So we're now on to the final two. And these are in a group on their own. So like the gas giants, the terrestrial planets, these are now ice giants. These are the furthest away from the sun. These are actually the coldest. Interestingly though, Neptune does have a bit of an excess of thermal energy. And Neptune has the fastest wind speeds in the solar system. And winds are generally driven by the sun. Think about hurricanes and how storms are formed on Earth. We need the sun to basically keep those going. So as we get a colder planet, we'd expect those wind speeds and storms to be less. But actually, Neptune has big storms, just like Jupiter, but it has even higher wind speed, which is a little bit bizarre. So I'm not really expecting, I don't know what to expect flavor-wise here, but they're quite cool. So maybe something quite fresh would work here. You know, maybe like a mint or something. But for Uranus, we've got a blueberry ganache. Neptune, we have a toffee caramel. And again, just like Jupiter and Saturn, I'm expecting these to have a soft outer part, because these are essentially, you can think of these like super terrestrial planets. They're not quite sub-Neptunian because they are Neptunian size, but they'll have this outer gaseous envelope with a rocky core, which could have been a terrestrial planet if it had stopped formation of that process, but instead it's carried on accumulating a large atmosphere. And now we're ended up with an ice giant. They're ice giants because they're further out in the system. If they were closer in, you'd have something like a warm Jupiter or a hot, not Jupiter, a hot Neptune, Uranus, things like that. So Uranus, blueberry ganache, that sounds like quite a soft flavour, not too intense. That could work quite well actually, given that it's further out. Oh, actually, this one might actually even break open. There we go. So actually, we've got nothing in the centre. I don't know if you can see that. There we go. Nothing hard in the centre like we would do with the actual real planet, but it looks like it might be quite soft, which again is going to kind of work well with this outer atmosphere level, or this gaseous envelope we have around the central core. So, yeah, it's a very soft kind of inner layer. The outer crust, it's not really very crispy. Again, that kind of works well. It's only really Saturn that had that kind of crispy part, but we could kind of put that down to maybe having the ice ring around it. I'd expect a crunch there because of that, but no kind of central hard part. But the flavour, I think, works well for Uranus. It's got a more subtle flavour, a lighter flavour. Again, we're getting cooler. I think actually that one works really well for Uranus. And there we have Neptune, our final one. This is our furthest planet in the solar system from the sun. There might be other planets that we haven't found yet. There's some kind of debate there where we might have some further out. But this is the furthest one that we know about. Obviously, we've got Pluto and the other dwarf planets, but they're not planets anymore. They were kind of downgraded, or should I say Pluto was downgraded some time ago. So Neptune, this says toffee caramel. Now, that sounds like quite a strong flavour, and I'd expect it to be similar in texture to Uranus because they're very similar. In fact, Uranus and Neptune are very similar composition-wise as planets. So a hard central core and a softer outer part would work well for this planet here. And that, if you can see that, that's very, very soft. Texture-wise, that kind of works quite well. There's nothing hard in the centre though. The flavour is quite strong. I'm not sure that the flavour represents Neptune particularly well. But the inside parts definitely represent what we'd expect with that kind of quite low density gaseous envelope that we have there. So that's all of the planets and the sun done. If I go back to look at those, I think probably the one that works the best, maybe I'm thinking kind of Mercury or Mars, because Mars had that caramel salt, had a crunch to it, and that worked quite well given it's a rocky terrestrial planet. Didn't have any of that molten stuff inside. And Mercury, again, the flavour of cherry and the chili, quite an intense flavour, quite crispy as well. That worked well given it's a rocky terrestrial planet, quite an intense flavour. Venus, I think, the flavour's too soft, needed something a lot more intense given how hot that it actually is. But overall, I enjoyed all of those. And if you have any ideas for other kind of space-related video, or even if you enjoyed the video, found it a little bit different compared to what I normally do, then let me know, because this is something I thought I'd just have a go at, because I do really enjoy food and that sort of stuff. But I also am a space scientist, a planetary scientist. My main interests are in the planets. And just coming across this was just really exciting, actually, because it combined my two interests, really. So anyway, thanks for watching. And if you enjoy, let me know. And maybe I can have a look at doing some other interesting ones like this.